Hey guys, this is Lucas from Better Coding Academy, and in this video I want to talk about modifying objects and arrays without mutating the original object or array. So I've got an object and an array over here, and I want to show you a few things here. So let's just take a look at our object for a second. We can do console.log my object, and it will show that over here on the side. And what I can do here is I can do const my object2 equals my object like so. And what I'm going to do here is I'm going to write my object2 dot b equals 3. So now you'll notice that if I do a console log of my object and my object2, both of them now have a value of b being equal to 3. Now the reason for that is because when we do my object2 equals my object, we're not actually copying the object and all of its values. We're actually using a reference. So all objects in JavaScript are stored in memory, and the variables themselves, or in this case the constant, doesn't actually store the object, it stores an object address. So it stores a reference to the object, and that is a location in memory where the object is stored. So in this case, when we do const my object2 equals my object, I'm actually just copying the reference from my object also to my object2. That's why when I do my object2.b equals 3, it changes the value on both. So because it's referring to the same reference in memory. So in order to get around this problem, what we can do is instead of doing my object like so, we can use the ES6 syntax of the triple dot, also known as the spread operator. And what this does is this actually does a shallow copy of all of the things inside of my object. In other words, it copies a equals 1 and puts it into this new object. It also copies b equals 2 and puts it in this new object as well. So now if I do my object2.b equals 3, you'll notice I have my object is a1b2 and my object2 is a1b3. Now, you might have noticed that we can shorten this a bit, and that is true. So I can get rid of this line and write b equals 3 inside of there like so, and you'll notice that we still get b equals 3 inside of my object2. So this is essentially how you would do it, and for an array it's the same concept. So let's just say I wanted to have a new array, my array2, and I wanted to add the number 4 onto the end. Then I would do square brackets dot 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 my array, and then I would write the 4 like so. So now if I do console log my array and then console log my array2, you'll notice we get 1, 2, 3 and 1, 2, 3, 4. So now these two are separate arrays. One more thing I want to point out here before I move on is essentially this is how you can tell if two constants are pointing to the same object in memory, is you can do console log my object triple equals or double equals my object2. And you'll notice that in this case it gives us false. But if I went over here and I did my object2 equals my object like so, you'll notice that this now becomes true. So this is a crucial difference, and if I do dot 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 my object, you'll see I get false again, even though they're the same values. Because now this has created two objects in memory, so that these two references to the objects are now not equal because they reference different locations in memory. Whereas if I just do my object like so, I'm using the same reference in memory, which is why it's true. And the same thing applies for the array. So if I go down here and write my array equals my array2, and actually I'll change this back to the original code I had here. So like that, and I go down here, you'll notice that these two aren't the same. However, if I do my array like this, and then if I do like say my array2 dot push 4, you'll notice I get 1, 2, 3, 4 in both of them, and I get true over here. So now dot push in particular, I want to just quickly talk about. If you have a look at all of the array methods, maybe you can search it up on the MDN, so the Mozilla Developer Network. If you search it up, you'll notice that dot push is a mutating method on an array. So when you run dot push, it mutates the original array. So in this case, it changes the values of this to become 1, 2, 3, 4 like so. If you don't want to mutate, what you can actually do is you can use, in this particular case, let's just say you didn't have access to ES6, you can do concat 4 like so, and this will add the number 4 onto the end. Because concat does not mutate, it creates a new array, which allows us to add the 4 onto the end like so. But like I said, in modern day JavaScript syntax, you can just do something like this and it will work totally fine. And if you wanted to put a number at the start, you could put it at the start like so as well. So This is just a really quick look at making sure we don't mutate objects. Now, the reason why this might come in handy is if you have certain bits of data in a JavaScript object and you so-called copy it onto another object and you want to keep those two now separate, what you want to do is you don't want changes on your second object to affect your first object or vice versa. So you want the two to be separate where possible. And by using the spread operator, it allows us to do this for a single level of complexity. However, one thing I did not show here is when you have nested levels of complexity. So let's go back here, let's get rid of all this code, and let's just say that we have A, and then we have B inside of here, and let's just say we have C equal to 3 here, and we have D equal to 4, and E equal to 5, like so. So this one here, you'll notice we have an object, and inside of it is also an object, which also contains an object here. So now you'll notice that if I do const my object2 equals ... my object, and let's just do the console log thing here again. So my object and my object2, and let's have a look at that. So now you'll notice that if I do console.log my object triple equals my object2 like so, you'll notice I get false. However, if I try to change one of the nested properties, let's just say I try to change D from 4 equal to 5 on my object2. If I do my object2.a.d equals 5, you'll notice what actually happens is both of them still update. So I'm actually mutating the original object. And the reason for that is because in this code here, when I use a spread operator like so, and I normally like to put spaces there, but when I use the spread operator like so, I'm only doing what we call a shallow copy. So a shallow copy only copies one layer of elements. So for example, in this object here, this is the top layer here. So we've got A, and it basically takes A, but it doesn't go through here and copy everything inside of here. It only does a single layer. So it only does A, and then it takes this same object, the same reference location in memory, and it just puts it straight into object2. So if you'll actually notice, the culprit here is if I do console.log my object.a triple equals my object2.a, even though my object does not equal my object2, my object.a is triple equal to my object2.a. They're the same thing in memory. So what I actually have to do is if I want to change D equal to 5 over here, I would have to do ... my object like so, and let's just spread it out a little bit. And I'd also have to do A, and I do ... my object.a. So I'm basically saying, let's spread out my object.a as well, do a shallow copy of that, and then I'm going to set D equal to 5. So now by doing this, you'll notice that I have D equal to 4 here, and D equal to 5, and now my object.a is not equal to my object2.a. So this principle also applies if you're trying to change C, let's say from 3 to 5, 3 to 5 as well. Then I would go inside here, I'd write B, and then I put a comma there, ... my object.b, and I write C equal to 5. Hey guys, it's Lucas, and I'm just editing the video now, and I just saw that I put my object.b in there, where that should have actually been my object.a.b. Now that was my mistake, and the reason that it was still working fine was because we had no other properties inside of the b object. So when I did ... my object.b, when I tried to spread undefined into the b object there, I don't actually get any error. But I apologize for that. I only just picked that up in the editing process, so I hope that's not confusing to you. And now you'll notice I can change that inside of here as well. And if you don't do this, if you don't make sure that each layer gets copied, what you'll find happens is we actually won't be able to modify the layers down without once again causing a mutation. Now the same thing is true with an array, so I will showcase the syntax for that real quick. Const my array is equal to, and let's put square brackets, square brackets, square brackets inside of here, 1, 2, 3, 4, and let's just say 5, 6, 7, 8 like so, and let's copy this thing and put one more of them down here like so. So now I've got these two over here, and I do const my array. Let's just say I want to change 5, 6, 7, 8 here to 8, 8, 8, 8. Then what I would do is I would go const my array2 is equal to square brackets, and now the way I would do this is I would have to make sure that I don't copy this element here as well, because with an array you can't do ... my array and then try to modify one of the existing elements. If you want to do it together in one go, you have to do something like this. You have to do my array.slice1. So by writing .slice1, I'm taking in basically the second array here, and what I will do is I'll actually update this to use A, B, C, D, so it's a little bit clearer. So now we have A, B, C, D, E, F, G, H here. Now let's go down here and have a look. Console.log my array2. and you'll notice we get just A, B, C, D, E, F, G, H. We don't get this part here. Now, if I want to put that part back in, I have to put square brackets here, and then I put a comma here. I would have to do my array 0 like so. So this is one element, which is essentially 0, 0, which is this one up here. And if I want to change this one, I would have to do comma, and then I would write my array. I would put square brackets, my array 0, 1, and dot, 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 that. And let's just say I wanted to replace these three numbers here whilst keeping the fourth one. Then I would have to write my array 0, 1 dot slice 3 like so. So that will put the 8 in there, which is the final number. And I would write the three elements before that. So let's say I want to put 8, 8, 8 like so. And now you see we get 8, 8, 8, 8. And that is how you would change it. And I can do a console log of both. And you'll notice that I get the two as being separate here whilst copying everything else. Now, what you might have seen from this is that the syntax becomes incredibly complex and it becomes incredibly difficult to do, especially in the case of the array, because you can't just reference them by name like an object here. You'd have to actually slice them and take out bits of it separately. So in order to get around this problem, what we can actually do is just something I wanted to point out, which is something many novice programmers use, is something which we call JSON.stringify. And what this will actually allow you to do is this is kind of like a hack to get around this whole problem here. So let's just say we had this array here. And I'm going to get rid of this bit of code. So my array, and in order to change my array to, what I would do is I would write, let's just say I wanted to change this number 8 to an A, or a capital A, then I would do const my array 2 equals json.parse json.stringify my array. So what this would actually do is it would turn this whole array into a string using stringify, and then it would parse that back into a new array or new object set. Now, this would do what we call a deep copy. However, the problem with code like this is that it doesn't work for all objects and it doesn't work for all arrays, because in objects in JavaScript, you might also have functions, you might also have classes, and even in some cases, you might have code like this. Let's just say we have obj1, and then const obj2 equals a obj1, and then we do obj1.a equals obj2. So now we can do something like console.log obj1.a.a.a.a.a, and you can just keep going, and you see it becomes a circular reference. So some code like this, you just can't do json.stringify on it. So if we actually try to do json.stringify obj1, you'll notice that we get an error because we're trying to convert a circular structure to JSON, which is why this code doesn't work all the time. But this is what some new programmers, myself included back in the day, used to do. So then I would do my array 2, 0, 1, and say I want to change the 8 to an A, then I'll do console.log my array and my array 2, and you'll notice we get this one here becoming an A. However, like I said, this is not ideal. There are two main problems here. Number one problem, doesn't work for all cases. Number two problem, you're actually using up unnecessary amounts of memory, because now you just copied this and you also just copied that and that, even though none of these have actually changed or need to change. So the solution I'm going to showcase here first includes a JavaScript library. So I'm going to use Lodash, although you don't need to use Lodash. There are other options out there and you can even write your own. So I'm going to first put in Lodash though. So I'm going to install an npm package here, Lodash right there. And I'm going to add Lodash. All right, so now what I can do is I'm going to write import fp-set from lodash/fp/set. Now, lodash/fp basically is Lodash's functional programming set of functions. If you don't know what Lodash is, you feel free to search it up on the internet. Essentially, it's this toolkit, a massive toolkit of tons of functions that come in handy, like little utility functions within your code. So now let's put back let's put back this my array thing we've got here, and I'm going to write import fp-set from lodash/fp/set. Now I'll show you how to use this one in particular, but like I said, this isn't the only option. You have many options out there, all available for you, that do pretty much the same thing. So now let's go here and write const my array 2, and this is how you would do it. You write fp-set, and now we want to change this 8 to an A. So what I would do is I would have to write square brackets 0 for this array here, and then square brackets 1 for this array here, and then I would have to write 3 for this thing here, like so, and I would change this to the letter A, and then I would do this on my array. So now if I do console.log myArray like so, and console.log myArray2, you'll notice that this one here is changed to an A. And this, look how simple this is. It's just one line of syntax, and it also works if you had an object. So let's just say I didn't want to change this. I wanted to change a random object here with name equal to Lucas, and I wanted to change that to, let's just say something else here. I would do like square brackets 1 and then square brackets 2 because this is the third element here, and then I do dot name, and let's just say I want to change it to A, then you'll notice that it becomes A over here like so. And the really cool thing I wanted to point out here is, if you remember I said about JSON parse and stringify, is that there is an issue to do with basically unnecessary use of memory. Now, in most cases, it's not an issue, but it's something that I feel like I should point out. In this particular case, the only thing that's being changed here is this object. Everything else here stays the same, and I can prove that to you. If I do console.log myArray triple equals myArray2, you'll notice I do get false because these things here have changed. However, if I say for this object, this array up here, if I check that, you'll notice that my array 0 and my array 20 are actually still the same element. Now, the reason they're still the same element is because they don't need to be changed. In this particular case, I haven't modified anything here. So therefore, they don't have to change, and you don't have to create a new copy. So this in JavaScript, in the JavaScript memory, is referring to the same array. And that's really cool because that just basically saves the space for us in terms of the program. And what we can also do with Lodash in particular is we can actually chain these ones together. So I can chain multiple changes and put them together to run all on the same time on the same function here. So what I can do is I can do import underscore from Lodash, or I can just include the method specifically. But what I can do here is I can write underscore.flow, and if I put square brackets here like so, I can put this one change in here, and I can also put fp set. Let's just say I wanted to change this number 8 back to an A. I do 0, I do 1, I do 3, and I change that to the letter, let's write the number 8 in there like so, and then I would write my array like so after it like here. And you'll notice that we get 8 changed and also A. And now you'll notice that it becomes false here. And the reason it becomes false is because in order to change this to an 8, we have to create a new copy of this whole array here. However, we do not have to create a new copy of this array here. So what you'll notice is if I do square brackets 0 and square brackets 0 here to refer to 1, 2, 3, 4, you'll notice that it actually still gives us true. And I think that that's actually really, really cool, because this essentially is just changing exactly what we need to change. And if you don't know, underscore.flow basically just allows us to run both of these functions on my array, one after the other. So that's just what it does here, and that's how it is useful. So this has been, well, I would say short, but it's been a 20-minute video on how to prevent mutation on arrays and objects where you don't want that to happen. I've showed you around Lodash, but as I said, there are other ones out there. One that you might want to also have a look at is called Ramda, and that's just built completely around functional programming. But that's all I've got for you in this video. I'm Lucas with Better Coding Academy, and see you guys later.